Okay, everyone, welcome back to lesson 3 in this 3-part series. We're talking about the mixed model line design process and how to make this a reality in your life. Now, just to do a quick review, if you haven't watched video 1 and video 2, you can get access to those right above this video. And just recommend you click on 1 and 2 and get that background. But just to recap, in lesson 1 we talked about this mixed model line design process, told you what it was, we defined it, and then we made a case for how important this is. And one of the statistics we shared with you is that 90%, in a study done at Toyota, 90% of the hard benefits of lean come from larger scale engineering projects, or essentially line design and material management type of projects, and not from small suggestions or individual Kaizen. That was only 10% of the total benefits. So we're focusing at the Leonardo Group, our company, and in this subject, focusing on that 90%. And that 90% is how do we become a lean process designer? And we shared with you that there is a step-by-step methodology. So we don't just be smart about it. You're not simply applying things like 5S and expecting to get the results that you're going to get from a full-blown line design project. So this is something that's important. It's important to you individually in terms of your career and your place in the world and your company, and also important for your company because you're going to be able to design really the ultimate, we haven't said this before, but this is the ultimate line design. In other words, you're going to be able to design a lean value stream that's unbeatable. And by unbeatable, I mean with those same processes, the same basic ground rules, no one could design it better in the universe, on the planet Earth. So that's what we want to help you to achieve, understand that methodology.
And we want you to be it. We want you to be the 90% guy.
The hero.
Not the 10% guy. So again, not to say that Kaizen is not important, but line design is where the majority of the benefits come from. On lesson 2, we talked about the steps, the roadmap, and the specific methodology to get to a mixed model line.
Now, this was a little longer, admittedly, but what are you going to do?
I think this one's going to be a little shorter.
Yeah.
Because on this one of the things we wanted to do was to address some of the questions we got. By the way, thank you very much for your feedback and your questions. And we wanted to address some of the questions that we got from you folks. So, Richard, you want to take a look at the first question? See if we have, I have it right here.
I have them here as well. First one is, if you mix products, the question is, if you mix products, so mixed model line design, doesn't that generate a lot of line changeovers? Well, good question. It could. It depends if you have changeovers between products. So there is a methodology in Lean called SMED, so changeover reduction. And certainly if you do have changeovers, the more you mix, the more changeover time would be required. That's something you can't just ignore or pretend doesn't exist. Now, in a pure mixed model line, like you might see at, say, one of the leaders in this methodology, there isn't a lot of changeover between products. Why? Because the materials are presented as they're required. They're either in front of the operator or they're delivered as required. So there's no line changeover for materials reasons. And the work content is balanced, or what we call level loaded, so that there shouldn't be big delays between products. So in the best of conditions, there are no changeovers between products. That one different product can follow another different product with a minimum of delay in between them. Now, if you have line changeovers for whatever reason, sometimes, for example, in medical products, you have to clear the line before you can build another product, right? That's regulated.
In the food industry, you have to clean up the line, and that will take time. So then you're shifting from building products one at a time to from flowing the individual product to flowing a batch, and that's okay. Flowing batches is also flow, and that is something we teach in class. What is the optimal size of that batch? Because sometimes saying, well, you can build batches sounds like license to go and build the next 2 years worth of a customer forecast. No, we do not advocate increasing number of changeovers willy-nilly. That's calculated. There's a calculation for that, and there's a methodology for flowing batches. So I hope that addresses that one question.
Okay. Here's another one. If we change the volume on the line, say on a daily basis, I think is what this person's saying, does the tack time change? because this could be every day. Well, yes, the volume on the line could change every day. Depends on the nature of your policy regarding customer orders. Some factories like to produce the same number of products every day, come hell or high water, and others are willing to let that vary depending on what actually is coming in the door and the work content involved. But does the tack time change is the question. And the answer is no, does not. Tack time is a calculated value based on a mix and volume of products that we use to design the line and calculate resources. Now, from that point forward, can the customer order something different than the original mix that we used to design the line? Yes, that's guaranteed. That is what's going to happen. If you had a day where the customer wanted exactly the same mix and volume that you used to design the line originally, that would be a miracle or a pure coincidence.
Absolutely. In other words, that's not going to happen.
It's not going to happen.
You design a mixed model line to an assumption of mix and volume, which is the forecast daily volume. You run it to customer demand. And yes, they will be different.
So when does tack time change? Well, it changes when you redesign the line and recalculate resources and rebalance the line. But in between those time periods, the tack time does not change. What does change, or what could change, is what we call the flow rate, but not the tack time.
Yep. I have another question here.
Yeah.
What information is available in terms of learning the method that you covered in more detail? Well, we're putting together a suite of information products for you. There is the live class that we teach with our colleagues at Toyota. Toyota Material Handling in Columbus, Indiana. We teach that class a couple of times a year. There is the online version of that workshop that we have. That one is on demand, so you control the speed. It is a substantial number of hours, but you control the speed, and it includes all the quizzes, all the lessons, and all the hands-on exercise, all the calculations, all the tools are provided. There is our book, The Complete Guide to Mixed Model Line Design. We also have a program called the Memory Jogger program. Basically is 50 weekly emails, weekly reminders of something you learned in class. So picture one slide, two slides, one key point that you learned in class. We remind you every week for an entire year. We say 50 weeks because we want to give you a 2-week vacation.
It's not 50 email. Well, it is 50 emails, but it's 50 short training videos.
Exactly right. Each of them is a training video. We basically remind you of something we taught you in class. And then there is the coaching for folks that want to get certified. We have a coaching program. So those are the tools we have available. Feel free to go to our website to check on the availability of those products. And we're going to have a chance to talk a little bit about that because we just can't take everybody. We don't have the capacity to take 1,000 of you. This is going to be a pretty small class that we're going to be able to take.
All right. Any other questions here?
How about this one?
The last one there?
Yeah, the last one. How many different products should you or could you build on the same line? How many products should you build on the same line?
Okay.
Well, ideally, as many as possible. However, there are going to be limitations. And again, this is a methodology we teach in class. There needs to be a process commonality, time commonality, material commonality. Those are the basic, that's the basic criteria. However, if you mix too many products and the volume is too high, you may end up with a tack time that is 2 seconds. Nobody can work in that time. So that is going to be a limitation. There may be also too much variation in standard time. You wouldn't want to mix a product that is 1 minute worth of work content with 20 minutes worth of work content. Very difficult to balance those two. Also, if in your factory, for whatever reason, you build refrigerators and golf carts, don't mix those. Those do not have either process commonality or time commonality or material commonality. So that is pretty much the answer to that.
If you have a volume challenge, meaning you have consistent processes and times and materials, but you just have too much volume, then one of the nice things you can do is just split that design into two, right? Design for half and increase the tack time on each of the lines. You could have more than 2 for that matter.
Mm-hmm.
There is kind of a sweet spot in terms of volume and tack time. If you get below 1 minute, now you're entering the realm of automation, because as we know, lines with too short tack time is very hard on the people working on that line. It's very boring, for one thing. It's very stressful. People don't like it.
Yeah.
So that's one challenge. The other challenge, though, is on the long side. Of course, that's not what we're talking about here. But beyond a certain amount of time, like an aircraft that takes a week to build, that tack time, that rhythm or beat, doesn't mean anything at that point, right? It's like a metronome that clicks once every 5 days. It's not much of a reminder in terms of keeping the pace. So in those environments, you have to do something altogether different, which is like to create an artificial tack time, just to subdivide that time into something that's more meaningful for the people doing the work. But the sweet spot is in the realm of minutes of tack time. That human beings can do the work if we're talking about human beings, but it's not too fast. So here's a case history for you. We've told you about all the hundreds of implementations we've done. Let's share a little bit of actual information. Of course, these are kind of the more outstanding examples we could give you. But here's one that both Gerard and I were involved in, which was a fun one. It was a scientific products company. I don't think I'll mention the name. It's not too embarrassing, but they were making catheters, so pretty high volume, pretty high level of automation, and they'd been growing like crazy. So we went through the same methodology that we just shared with you. We had products, had quite a few different configurations of the same product, and we had volumes. We calculated tack time, resources, etc. And when we did that, we came up with an interesting something that confused us immediately when we saw the results, because our calculations said that they needed about half the number of people that they actually had. And our first thought was, well, we did something wrong. There's something wrong with our calculations. It can't be that they have double the number of people that our resource calculation said they actually needed. But upon further examination, we realized that was the case.
Which, by the way, is another excellent reason to have this methodology under your belt. Why? Because
sooner than later.
Exactly.
Yeah.
You're going to reach a point at which the data or the information that you're looking at is not convincing. It doesn't clear the common sense check. You can go step by step backwards and figure out where the mistake was made. And it has happened to me that at some point in time we made a data entry error, and what should have been an 18.05 was 1805. It was just a data entry error. But in this case, we did go upstream step by step, and there were no errors.
Now, fortunately, the company was still growing rapidly, so they're able to absorb that excess in a more rational kind of way. They had a lot of temporary people that I think they did let go, but they didn't have a massive layoff of permanent employees. So that was the good news of that, but it could have been bad. And it was quite embarrassing for the management to realize that they'd been just throwing people at a growth issue without actually going through the science.
And it was, to a certain extent, the quote-unquote curse of being so successful. They were making money hand over fist. And then throwing people at the problem, that was never too costly. So they kept bringing attempts on board non-stop, throwing people at the line, thinking that more people would save it. And believe me, if you ever heard or you never heard about the principle of diminishing marginal returns, stop now, Google it, and you will see that live in a mixed model line, or actually any line. The more people you throw at it, the lower your productivity. Guaranteed. After a certain point, all productivity can do is go down. So that's one. Another one that we want to share with you is this concept of having a roadmap and making line design a core competency for your company. Again, it's not new. As a matter of fact, we heard that John Deere has made their own roadmap. They have a roadmap that has a lot of internal steps. It's not just line design, but this is how you design a John Deere line. And these are all the steps you need to follow. These are all the forms you need to follow. These are all the capital requests you need to follow, all the formats, everything in one place. And that is a tool that's being provided to their industrial engineers, making their jobs of designing lines, which, by the way, for them, designing a line, they have acknowledged is a core competency. They must get good at designing lines.
Yeah, and here's a company that's been growing in every one of their major markets worldwide, growing market share year after year after year.
They are the undisputed number one. They
Yeah.
are the undisputed number one.
Yeah.
And their products are really really cool.
Third example, this is the classic example. It almost goes without saying, but if you were to go into a Toyota factory, almost any Toyota factory, and be able to pull back the covers and see how they're doing things, it's pretty much the way we're describing them to you.
Yeah,
with whatever Toyota enhancements and details they have, which we don't know about,
and terminology.
Yeah,
right. But
Japanese.
Yeah, exactly. But this is the methodology. So again, we're recommending strongly that you learn it.
So here's the big picture that we want to share with you in terms of becoming a mixed model line design expert. That's our goal for you. It's a worthy goal because, again, this is something that is one of the highest value add skills that you can have in any manufacturing company, but by far. In other words, it's hard to find any other position, any other kind of job skill that's going to bring more value to your company than having this skill. So worthwhile learning it. But the question is, how do you go forward with this? And so what we're presenting here is a couple multiple step opportunities, right, for you to go forward. So let's go through the process we would envision. First step is you need to get educated, right? So you need to learn the material. This has been a good step, this 3-part lesson.
It's a crash course,
yeah.
So it cannot be the complete class. But yes, first thing you need to do is to learn about it. Reading a book, not enough. Taking a class, not enough. But that is where you need to start.
Okay, so I think Deming was big on this point too. W. Edwards Deming said you need to base your actions on theory, on knowledge, right? So you have to have some kind of structured knowledge that you're going to apply and test, right, in the world. So that is the first step.
Now, those of you in my engineering brethren, I am an industrial engineer. Don't think that this is not for you. You did not learn mixed model line design in school. I know that because I didn't teach it to you when I was a university professor. So this is not taught in universities. You need to learn it outside of the realm of a university. So think about sticking with us, learning this.
You know, Gerard and I both read a book recently called The End of College. And we won't get into that in too much detail, but the basic, in a nutshell, the basic premise was that the world is changing so quickly these days that the thought that you're going to go to a university and spend 4 years or 6 years and come out at the end of that with current, information, knowledge that you can apply is becoming more and more unlikely because the pace of things is changing so quickly that our educational model needs to change. Yeah. And so this is another way of actually changing that model and getting intense training in a particular high value, high leverage subject like mixed model line design outside of the university system, really.
For someone who is adept to computer coding, working for Google is a dream. And working for Google nowadays means going to a 6-month bootcamp, learning Java and being hired out of that. Google is hiring for skills, not for degrees. And we're beginning to see that more and more outside of the high-tech companies. More traditional companies, they're going for the skill, not the degree. Now, are we telling you to not get a degree? Absolutely not. Absolutely not. But make sure that you do get the skill.
And this is really lifelong learning as well, right? Because as things accelerate, as the pace of change and technology accelerates, you're going to have to be learning the rest of your life. That applies to all of us.
So step 1,
okay,
learn the skill, learn the tools.
Okay.
Yeah.
Step 2, Because you've gone to a class or because you've read a book doesn't mean you got it. So typically in the educational process, there's a step we call testing, right? Where you validate your understanding, or someone else, an outside entity, would validate your understanding of any particular subject matter. So we think that's a good idea too. Sitting through a class doesn't mean you were awake, number one, and number two, it doesn't mean you actually understood correctly the material that was being presented, even if it was presented flawlessly, right, and correctly.
Yeah.
So there's a testing step that it's not a huge step, but there's a testing step right after this educational phase.
So what we want to do for our students, the ones that take, for example, the online classes, we leave the online class available to you to review it as many times as you need so you can prepare for the test. Why is testing important? It activates different part of the brain. Learning something activates a part of the brain. Having to recall to answer a question on a test activates a different part of the brain.
And the fact of the matter is, if you know you're going to be tested on a subject, you actually pay attention more than if you know you're not going to be tested on it. That's just the fact of the matter. So having a test at the end of this road is actually a good way to learn, to retain your learning.
So step one, learn it. Step two, be tested. Step three, practice it. And that is the third leg of the stool. We want you to get practice with the Mixed Model Line Design project, and we will provide the coaching. That's the goal. Now, after that, after you finish that, we will issue a certificate, and after that, you will receive the weekly reminders, the weekly mini lessons on Mixed Model Line Design. So, learn, be tested, do a project, and after that, be reminded for a year. Now, we can't take everybody on this. We wish we had the capacity to let 1,000 of you get in, but we just don't have that. We're going to have to limit this, although we want to expand it as much as possible. But right now, we need to limit the capacity to classes of 30 people at a time. I know that's not a lot, but that is what we need to do. We have a limited number of seats for this first class of 30 folks.
Right. So we're going to be sending to you in a couple days a little more detail on this offer. But let me just summarize it in a nutshell. And we're doing this under an umbrella we're calling the Lean Design Institute. Under the Lean Design Institute, you have a chance to get trained, and that can be either with one of our live workshops that happen periodically, or in an online course, or outside. But you need to learn this methodology, which is the way we teach it. Number two, you need to pass an exam or a test of this knowledge. That's step number two. And this would be an online test that you take. It's about 120 questions, say a minute per question. That's a 3-hour test. So this is pretty substantial, but it's broken into chunks, so you don't have to take it in one sitting necessarily. And then the third thing is you need to do a line design project with our mentorship. So we're providing to you a roadmap. Again, this is online to help you structure your project, but you would need to do an online project. And that could be a whole new line design if you have that. Pretty rare opportunity, but if you have that, great. It could be something that you define for yourself as a piece of an existing line. It could be cellular design. It could be a variety of options, and we're open to those, but you would need to actually apply, submit your concept for a project and get that approved, and then go do it.
And to get certified, we're going to make absolutely positively sure that you're following the roadmap. For that, there will be a series of documents that you need to complete, and they will ensure that you're following the roadmap. And every document will be provided, all the roadmaps will be provided, all the calculation tools will be provided. We're going to make sure that we give you everything you need to be successful with your project, and we're going to do everything in our power to make sure that you do get certified, you do become an expert. And after that, we're going to issue a certificate along with an electronic badge, which, by the way, electronic badges is the wave of the future in proving that you have a certain skill, rather than writing that on a resume. On the resume, what we're beginning to see in high-tech industries. People are writing down just the badge numbers for their accomplishments, and prospective employers can check on those badge numbers and see that they completed a course, and they get to see everything. So imagine on your resume having all the stuff we're talking about in just one single number.
So this is a credential, right, that would stay with you the rest of your life, essentially. That's going to really determine your future, I think, if this is the future you've decided to make for yourself. But it's going to be work, right? This is going to be substantial work. You have to learn the material, you have to pass the test, you have to do a project. So this is an investment of your time as well, but well worth it, because this is really going to give you a standing and a credential that you're going to be proud of, and that you're going to be able to take forward for the rest of your career.
And the good news, this doesn't need to take years. This is going to take months at most. So hopefully that answers some of your questions. And since we're talking about questions, please make sure that in the comment section you give us your comments. We'll do everything we can to address those on the next video. We're going to have one last video for you. We're going to address some of your questions, your comments. Let us know if you're liking this. Let us know if you find this information valuable and what else you would like us to discuss.
Yeah, and a lot more detail on this program we just described to you in the next upcoming video in a few days.
Yeah, and we'll be opening up for registration at that time. Thank you all. See you next time.